Welcome back, students. In today's video, we'll be exploring and understanding the relationship between current, voltage, and resistance. Stay tuned in Teaching Science. To help us understand the relationship between current, voltage, and resistance, we will be using this, an electronic device or electronic sprayer that we've been using in decontaminating, if not disinfecting, public school, along with the personal protective equipment, because I am part of DepEd Cebu City Division Response Unit. Let's dive in. The water passing through the tube is the same as the electrical current passing through a conductor. The international system of units of electrical current is ampere, named after the French scientist and mathematician André-Marie Ampère. Italicized and capitalized letter I is used as a mathematical symbol for current. If we increase the pressure from the water pump, the water current also increases because the pressure pushes the water from high potential to low potential energy. The electrical current is pushed by the same manner. We call it as voltage. To make it simple, voltage is the potential difference between 2 points which causes current to flow in a circuit. It is the force required to make the amount of energy from one point to another. The SI unit of voltage is volt, named after the Italian physicist Alessandro Volta. Italicized and capitalized letter V is used as mathematical symbol as well. If we continue increasing the pressure here, the current will also increase. If we reduce the water pump here, the pressure from the water pump, the current will also reduce. But sometimes the amount of water is beyond what we need. So what are we going to do is we usually connect this regulator at the tip of the nozzle, like so. The purpose of this regulator is to limit the flow of the water current. So the same as in the electronic concept, it's the same as a device called resistor. Resistor is a small component that hinders the flow of the current. If the resistance of the resistor is high, then the flow of the water is controlled. If the resistance of the resistor is low, the current is high. Are you confused? If you are, then don't worry. We'll be using a simulation program called Proteus to help you understand the concept of electricity, and of course to understand as well the relationship between voltage, current, and resistance. Proteus is a simulation program that will give you an upper hand in your electronic designs. It is also very useful in running your Arduino program before you run the program in actual Arduino board and component. Let's proceed. Welcome back, students. In this part of our lesson, we are using Proteus to simulate the relationship between voltage, current, and resistance. Earlier, you saw that the water current increases as we increase the pressure from the water pump, and the flow of the water current is reduced or controlled after we connected the water regulator at the tip of the nozzle. In this part, we are using Proteus to simulate the same thing, but instead of using the electronic sprayer, we are simulating a circuit here. So we have two circuits. Both circuits have the same source, 9-volt battery, the same component. We have the switch, and we have here the rotor or the motor itself. When we close the circuit, meaning we switch it on, observe the direction of the rotor. Now, as you can see, the rotor rotates clockwise, meaning the electrical charge or the current flows from the positive terminal of our source, which in this case we have the 9-volt battery, then going to the switch, then to our load, then out from our load, then go back to the negative terminal of our source. Now, in circuit 2, we rearrange the connection of our load to our source. Now let's run this simulation. Right. The rotation of the rotor is counterclockwise because our connection here is from the positive terminal on this side going into the load, then out from the load, then to the switch, and back to our source. Let's stop the simulation. Now, to fully understand the relationship of the voltage, current, and resistance, we'll proceed to circuit number 3. In circuit number 3, we connected a device here called the ammeter and the voltmeter. Now, the ammeter is a device that measures the flow of the current, while the voltmeter is a device used the flow or the amount of voltage that moves within the circuit here. We're using the same circuit, but we have attached another device just to measure the flow of the current and the amount of the voltage here. Now, how to connect the ammeter? The ammeter is connected directly in the lines, okay? Directly in the line, while the voltmeter is connected across our load. Now, if you notice, there are two ammeters here because, as I've said, this will really measure the flow of the current. If the ammeter is connected properly, then our display here will show positive sign. If it is wrongly connected, our display here will show a negative sign. Let's run the simulation. So we have here no flow of current, and of course we have no voltage here. Now remember, volt is the amount of force that push the electric current or the electrons passing through the conductor, the same as passing the water in the tube of our electronic sprayer. Now, if you notice, we have here a current of positive 0.01 amps, and we have here a voltage of 9 volts. And in the second ammeter, it shows here negative 0.01 amps, meaning our ammeter here is connected wrongly. Okay. Now, so if the current is low, meaning there is something here that reduces the flow of the current. What do you think is it? Right, it is the resistance. Stop the animation. Simulation rather. Actually, our load itself is also a resistor. It has its own internal resistance. In this case, the internal resistance of our motor is 800 ohms. Now let's reduce it to 100 ohms. Let's run this simulation again. Our current here increased from 0.01 amps to 0.09 amps, and our voltage here, our force that push the current slightly decreased because our internal resistance here also decreases. But what will happen if we increase the internal resistance of our motor? Stop the animation. Right. Of course, it will decrease the current. Let's increase the internal resistance to 400 ohms. Let's run the simulation again. Now, from positive 0.09 amps, it reduces to positive 0.02 amps while increasing the voltage here. But if you notice, our rotor here slightly change or not the speed of the motor, the rotation of the rotor. We cannot really tell if there is a change of the uh, rotation of the rotor here. That's because we haven't attached something or a external resistance that really hinder the flow of the current. Let's stop the animation. In circuit 4, in circuit 4, we added an external resistance called the resistor. Okay? We added an external resistance called the resistor. In this case, our resistor resistance here is 150 ohms. But let's reduce it into 100 ohms. Now, before we proceed on the in the simulation, I want you to calculate. I want you to predict the amount of current flow here, the voltage, and the speed of our rotor if we have an external resistance of 100 ohms. I'll give you 1 minute. Time starts now. To calculate the total current in the circuit, you simply divide the voltage of the circuit by the total resistance within the circuit. Time's up. Now let us hear your production. How much is the current flow, and what would be the what would be the speed of the rotation of our rotor, and what would be our voltage here if we run the simulation with an external resistance of 100 ohms? Okay, let's try your production. Let's run this simulation. Remember, on the third circuit, the speed of the rotor here is quite fast compared to the next, but we do not know yet. Let's run the simulation first. Now, our circuit here has a current flow of positive 0.04 amps with a voltage of positive 8.99 volts, and the speed of our rotor here slightly decreases. Okay, because we have here our external resistance. Let's stop the simulation rather. Let's increase our resistance to 400 ohms. What do you think will happen? Let us see. Let's run this simulation. And of course, it reduces even further to positive 0.01 amps, and our voltage slightly increase to 9 volts. Of course, the same of our source, it will not go farther of 9 volts because our source is 9 volts. And the speed of our rotor continue to decrease compared to our circuit number 3. Now you've seen the simulation using the Proteus. You've seen the relationship of the voltage, current, and resistance. You've also seen the analogy of the water current using the electronic sprayer, of how the water current increases as we increase the pressure from the water pump, and how the water regulator attached at the nozzle of the tube control the flow of the current. After seeing the analogy between the water flow using the electronic sprayer and the simulation using the Proteus, tell us now the relationship between the voltage, current, and the resistance. Right. To make it simple, if the voltage increases, the current also increases. But if the resistance increases, the current decreases. This is known as the Ohm's law. Now you know the relationship between voltage, current, and resistance. If you are new to this channel, please click the subscribe button and click the notification bell so that you will be updated of our uploaded new videos. So again, this is Teacher Philip. See you next time in Teaching Science.